Hi everyone, I feel like I should help you with some homework 2 problems which is based on the NMR spectroscopy. So let's go ahead and see how to solve these problems. Okay, excuse me. The first one, proton NMR located near electronegative atoms tend to be resonance, split, shielded, deshielded, none of the above, compared to proton nuclei that are not. Which one is the correct answer? That is D, right? D-shielded. D-shielded means the hydrogen doesn't have many electrons surrounding it. If it is closer to electronegative atoms tend to pull electron towards itself. So it removes electrons from the hydrogen. So hydrogen is more open for it to feel the magnetic field coming from the instrument. So that would be excuse me, more de-shielded. So as a result we will see the signal appear more downfield. We also call it as a higher frequency, which results in a large chemical shift or the delta value. Okay, so that is the de-shielded hydrogens. And number 2, how many signals would you expect to see the proton NMR spectrum of the following compound? Now, if we look closely, this molecule, how many different environments we have. So basically, you guys know NMR will give signals based on the different chemical environment. Meaning, you can look at the hydrogens and then the carbon that hydrogens are attached to and see if it is similar to the rest of the atoms or it is different. So the one here, the very first one, is a methyl group that has 3 hydrogens and a carbon chain. And then if you look at the next hydrogens, that is connected to a carbon which has a methyl group and a different carbon group. So that is again a different environment. And then the third one also a different environment. And then the fourth carbonyl group doesn't have any hydrogens on it. Okay, so because of that, that carbon will not give you any peak. And then you have the one at the very end, CH3 group. Okay, so that is also 3 hydrogens are different from the other hydrogens on the other carbons. So we would see 4 different environments or 4 different signals for number 2. And then for the number 3, how many signals would you expect to see for the following one? Okay, now in this one, how many do you think we have here? So this is a methyl group that is directly attached to the benzene ring. Okay, and then here you have another methyl group that is attached to a carbonyl group. So this group, carbonyl, this is called a carbonyl group. That is basically electron withdrawing group, okay, due to the resonance, due to the oxygen being electronegative, so the pi bond can be resonanced. Okay, and there are 2 with the 2 methyl groups. And then what about the hydrogens on the benzene? Most of the time you will see the hydrogens are not drawn for the benzene, but remember they are there. Okay, so there are 4 hydrogens. And you will find that most of the hydrogens are symmetrical, meaning they are chemically equivalent. Now the 2 hydrogens, you find these 2 hydrogens, this one and this one, they are chemically equivalent because they both of them are close to a carbon of the benzene ring that carries a carbonyl group. And then if you go to the other side, to the left side, you find a methyl group in the same distance. So the green 2 hydrogens would appear in the same signal, same environment. And then these 2 blue hydrogens would also be symmetrical. There is a symmetry in the molecule. They are going to be also in the same environment. So how many different environments we have, and as a result how many signals? We would have 1, 2, 3, 4 signals. Okay, that's how you find how many signals are there. Okay. Okay. And then the next one, number 4. How many signals would you expect in this molecule? Again, you need to remember that these positions you have hydrogens. Okay. And we are looking at hydrogens. In the proton NMR spectroscopy, we are only considering the signals of hydrogen, not any other atom. So how many signals do you think we will have in this one? So this is a one environment because it's between the two bromines. Okay. And bromine is an electronegative atom. So it can pull electron towards itself and have different environments of hydrogens in the benzene molecule. But if you have something that is not electron withdrawing, it would not create that much of a difference in the between the hydrogens. So you might see that all of them comes as a one multiplet. But since we have two bromide groups, it can give us different environments. So now these two, due to the symmetry, they are going to be in one environment. Okay, two hydrogens would be in one environment, and if you look at the other hydrogen, that would appear in a different environment. So this hydrogen would be another environment. So there are 3 different signals you would see for this one. Okay. Okay. And number 5, how many signals would you expect in this one? Now for the number 5, what do you think? What is the answer you got for this one? How many different environments? See, there are 1, 2, 3. 3 carbons carrying hydrogens, and then also you have a hydrogen on oxygen, alcohol peak. Okay, so if you expand this molecule to see how the connection, you will see there is a methyl group, and then you have carbon, hydrogen, OH, and then you have 3 hydrogens on this carbon. So how many different environments do you see here? So obviously this is one environment, right? And then the hydrogen on oxygen, alcohol, is also in another environment. It's 2 of those. Now what about the 2 methyl groups? Are they same or are they different? So these hydrogens, 1, 2, 3, and then these hydrogens, 1, 2, 3. So they are in the same environment. Remember, look at the attachment, how they are attached. So the methyl group, this one is attached to a carbon that carrying hydrogen and alcohol group. Same thing, this carbon attached to a methyl group carrying carbon, hydrogen, hydroxyl group and a methyl group. So they are chemically equivalent. Chemically equivalent hydrogens would appear as a one peak. So we will see 3 peaks in this one. So the answer would be 3. Okay. And number 6, which of the hydrogens give proton NMR with the highest frequency? Remember, highest frequency would give us if the hydrogens are more d-shielded. Hydrogen would be more d-shielded if it is next to an electron withdrawing atom. Between fluorine and bromine, which one is the more electronegative? Bromine? Did you say bromine? No, it's not bromine. It's fluorine. Fluorine is 4.0, just like your GPA, right? Okay, so fluoride is the most electronegative atom. So as a result, hydrogens on the carbon 1 would have the most highest frequency. Okay, this carbon right there, because